I was looking at the area here, and I thought maybe they didn't read the manual well to build the complete house, right, for IKEA. But anyway, let's go to microservices. My screen is not on yet. Yeah, there we go. Oh, skip myself. So this is my presentation, doing my microservices in Azure Container Apps. I usually do this talk in 45 minutes or 1 hour. Today I have 30 minutes, so I'm going to run very quick. But please know that if you have questions afterwards, walk up to me. I'm happy to answer them. So this is me. If you don't feel comfortable asking questions in the audience, please look at my handles. Then you can reach out on the internet and Blue Sky, because Twitter is not hip anymore. All right. Right into the microservices. So the first thing that you need to know, if you start writing a new software system, don't do microservices. So that is the end of my presentation. Thank you all for coming. I wish you a nice remainder of the day. No. For the simple reason that microservices usually require a lot of plumbing, right? You need the messaging and you need services to be able to communicate with each other, and you need to know that the data transferred back and forth between those services are eventually consistent. So you need to take all care of that. So if you start writing a new system, don't do microservices for the simple reason that it doesn't make sense to do all the plumbing up front. Make sure that you add value at first, and then when you walk into the situation that you really need to migrate to microservices, then you can. Right? So valuable reasons can be scalability. So imagine that you're a bank and you have one service where you do all the financial transactions, and you have the other services when someone can request an address change when they move to a different house. So they all have, these services have a different payload, right? I don't move that often, and when I do, it's one request to the bank, hey, I want to change my address, and then you need to take a picture of me. Yeah, come on. But the other service, the financial transaction service, here in the Netherlands, stores usually open at around 9, and then the financial transactions ramp up until 5 when most of the stores close, and then they gradually go down again. So the demand is very different, and the way that you need to scale your system is very different. That may be a good reason to identify, okay, this service, I'm going to grab this service apart, and then host that differently so that it can scale independently. Now this talk, when I mention microservice, I don't like to use the term microservice for the simple reason that it is opinionated. There are some rules when a service is a microservice or not. And for the remainder of this session, when I mention microservice, I just mean a workload that is hosted somewhere in a different area than another service. And all these services together form one single software solution. Okay, so it's not necessarily microservices, but it's services that you grab apart. You might also be, if you have a very large monolith and with a very large code base, it is harder to maintain. So maybe you want to be more flexible or agile in bringing your software into production. It might also be a good reason to grab it apart into a different service. If you have technology diversity, so for example, one backend API may be written in .NET, one may be written in Node.js, and maybe one other in Java. You can grab those all in one software ecosystem, but then host them differently for the simple reason that it's different technology. And last one, easier maintenance. Already mentioned, so if you have a large code base, then it may be easier to grab systems apart, so you have multiple smaller code bases that are easier to comprehend and maintain. So how do you move to a microservices architecture? When you have this monolith, in an ideal situation, you have thought up front, what are the different domains that I have in my software system? We now know, but this is a term that is popular for only 2 years or so. It's called a modular monolith, where you think up front, okay, I have a monolith, but I do separate my code base into different modules. For the bank, it may be, okay, this is my financial transaction service, this is my user address service, this is my account service, and whatnot. If you isolate your code inside your modular monolith, it's very easy for you to, in the future, grab these modules apart and host them separately as a service. So how do you move from this monolith, where I have isolated domains and isolated pieces of knowledge to different services. But the first thing you need to do is identify, do these domains have some shared code? And if they do, you grab that shared code apart and host it in a separate library, so that all these services can now use that library. Step 2 would be to make some layer of plumbing. So that's the messaging. I call that the integration layer because it's a layer that is used for the integration of your software, and it allows your services in the future to be able to communicate with each other. And then the most important step is all the way on top, is a proxy, or actually a reverse proxy. And this is a traffic manager. So in this situation, if you're here, the proxy or the traffic manager will redirect all the incoming traffic directly to your modular monolith, right, to the gray area. Now, if you're in this situation, you can grab one of these domains out of your code base and host it separately. You can test it, you can address it separately, and you can test it and see what's going on in your system. And if everything is fine, you configure the traffic manager, so the proxy. Okay, my service on this address is now hosted differently, and redirect the traffic to that service. So that will be a good strategy to move your system into multiple microservices, but also do that gradually. Grab one service, host it differently, test it. Okay, move the traffic now to that service. Now it's in production, and you can remove the code from your old code base. So how does Azure Container Apps come into play here? I think that Azure Container Apps is a very good service to host microservices in the Microsoft Azure Cloud. And there are, if you use containers, there are in Azure, I believe today, 7 ways to run containers in your Azure Cloud. I listed 3 here for the simple reason that I want to emphasize the ease and complexity between the services. So all the way on the left is container instances. It's a very easy service because you can grab a container, throw it at container instances, tell it to run it, and it will run the container for you, period. There's no scaling. You can scale, but you have to do it manually. There's no automatic scaling. There's no orchestration or whatever. It's a very basic service. And all the way on the right is AKS. It's an abbreviation of Azure Kubernetes Service, and it's as one-on-one as possible implementation of Kubernetes. There's one abstraction layer on top of it, and that is to integrate with Entra ID, or Azure AD if you like, for you to be able to identify users in your user management system, and to use managed identity and stuff. And there's a fairly new service. It's not actually new anymore. It exists for a little bit more than 2 years. And it's called Azure Container Apps. And it lives somewhere in the middle, because I think it is a service that is fairly easy to maintain. There's not a lot of knobs and wheels that you can twist and turn and to tweak your system. It comes with a fairly good default settings. But what it shares with Azure Kubernetes Service is that under the hood, it runs Kubernetes. So it does actually spin a full Kubernetes service up. And it does have an abstraction layer, but the abstraction layer is thicker. It's a lot smarter than the abstraction layer that you have for AKS. So there's one similarity. It integrates with Entra ID, so you get the advantage of using managed identities if you like. But there's a lot more. For example, KDA comes out of the box. That allows you to scale event-driven. We will dive a little bit deeper into that. So if you don't know KDA, don't worry. I will touch upon it. You have Dapper, which makes working with microservices as a developer. Breeze, again, if you're not familiar with Dapper, I will touch upon Dapper a little bit later in this presentation. So what does a container app look like? First, you need to know that you need to create a container apps environment. And that environment allows you to run the container apps. So a container apps environment contains 0 or more container apps. And the container apps, you can relate to the container app environment as your Kubernetes cluster. So you create a container app environment when the services that you run into the environment have some kind of cohesion. So they need to communicate with each other. They share a workload or data, or they need to interact with each other. So in case of the bank, Will be a good idea for the financial transaction service and the user registration service and the change my address service to run them all in the same Azure Container Apps environment. And inside that environment live your container apps. So those are actually the containers that you want to run. Now, when we zoom into such a gray area, the container app, oh, that's one slide. I'll go back to the previous slide. It looks like this. So a container app consists of revisions, and revisions are versions of your software. So if you have a new version of your software and deploy it, it will create a new revision in the container app. You can configure your container app to either run multiple revisions at a time or only a single revision. When you have a single revision, it will go ahead and spin up that revision right next to the old revision and then transfer all the traffic to the new revision and then deprovision the old revision. So you have no downtime, taken care of for you. No need to do anything manually. And inside that revision live replicas. That's how you scale. So if your service demands a lot of workload or gets a lot of traffic, you can scale it up and down. That will add or remove revisions. And inside those revisions live your containers. Now back to the previous slide. These are some rules of thumb that you can use to identify whether or not to create a new container apps environment. So again, if they have some cohesion, if they need to communicate with each other, if they integrate with Dapper, so if you use Dapper to communicate with other services or share state with Dapper, it's a very good idea to put all those services in the same container apps environment. All right, moving on. So ingress. Ingress is what we call for incoming traffic. By the way, container apps is a very good service if you create web systems like web APIs or a website. So I assume that most of the times when you create container apps, you want some kind of ingress. You want people to communicate with your service. And there are basically three flavors. If you don't integrate with an existing network in your Azure environment, you have only two flavors. So one is open the container app for the entire public internet, which is probably not a good idea in production environment. And the other one is limit the incoming traffic to my container apps environment. So with that configuration, you only allow traffic from the internal container apps environment, and all the traffic that comes out of that comes from outside the environment is ignored. Now the third option is when you integrate your container apps environment in an existing network. So you can build a virtual network in Azure, like a network that you have at home, and then use that as a security perimeter and whatnot. And you have settings and firewalls and everything that you can set up to make all the network traffic a little bit more safe. And when you integrate your container apps environment in a network, you have a third option, and that is okay, only allow traffic from my internal network. Now, when you run a production system, this would be the best option for you. So integrate it in your network, and then create some kind of mechanism in Azure that allows public internet traffic. So that will be app gateway or front door or some mechanism that identifies the traffic, finds whether or not it's legitimate traffic. Is that a good word? Or malicious. Filter malicious traffic out and then port it through to your container apps environment, and you're good. Now, who knows this circle? Okay, other question. Who can raise his hand? Okay, so this is the benchmark. Who knows this circle? Okay, I see few hands. So this circle, these are a lot of, these are a lot of tools that you can install when you run a Kubernetes cluster manually. So this is everything, not everything, but there's a lot of this that you need to know when where you're going to run a Kubernetes cluster. I don't run a Kubernetes cluster in production because I simply don't know these tools. I don't have a clue what they mean, and I don't have a clue how to configure them properly so I can safely run them in production. But with container apps, you can. For the simple reason that you don't have to deal with all these tools. You only have to deal with 3 tools. And the first one says Docker, and that's not actually fair because Docker is just a container vendor. You can also use Containerd if you like, or different mechanisms. But the change is for, it might be a change for you to work with containers compared to whatever system you like now. Then the second one is CADA. CADA is an abbreviation of Kubernetes Event-Driven Autoscaler. Very complicated word, but it means there are some events in your system, and CADA can identify those events and find out whether or not your service must scale to be able to handle all these events or not. And then there's Dapr. Dapr is a CNCF project, so it's and it really allows you to write microservices real fast. Localhost on your development machine, but you can also easily bring them to the cloud environment. And Dapr is by default integrated in Azure Container Apps. So if you're a .NET developer or Java or whatever developer, what you used to do is when you bring your software system in production, you push it to your code base, and then some mechanism automatically compiles that code into some libraries, and then you bring that library to whatever service in whatever cloud environment, and that cloud environment will run your code, and you're good. When you work with containers, it's a little bit different. I think by now we all know virtual machines. So it's not an actual physical machine, but you have a computer running somewhere in a virtual environment, and you can do whatever you want with it, get rid of it, spin up a new one when you like. That's the power of virtualization. Containers are exactly the same, but not for a computer, but for an application. So now your application, when you work with containers, you're actually virtualizing your application. And the advantage of that is that you can grab it, bring it somewhere else, plug it in, and it will run, except for the integrations. So if you integrate with, I don't know, maybe Azure Service Bus or whatever service in a cloud environment, that integration will probably break if you now grab that container and go and host it in the Google Cloud or in AWS, if you like. So you need to think of that. But the difference between working with containers and conventional code that you compile and bring into production is that now you need to create a container image. So your pipeline will go ahead and compile, and that leaves you with a container image. The environment that runs a container needs to be able to grab that image from somewhere and then run it. And that somewhere is what we call a container registry. So your CI/CD process now compiles to a container image, and it will push that container image to a container registry. The container registry is probably somewhere online, or at least available for the environment where you want to run the container. And then you go to your runtime environment and tell your runtime environment, or in this case, Azure Container Apps, hey, I pushed a new container to that registry, go ahead and run it, and these are your settings. That's all you need. That's all you need to tell the system for it to work, because now Container Apps will go ahead and communicate with that container registry, pull the container from that registry, and will go ahead and run it with the configuration that you brought to it. So it's a little bit different of a mindset working with containers compared to conventional code that you compile. So now I talked about Azure Service Bus. There are a lot of messaging systems in each and every cloud provider. I am a typical Microsoft developer, so I really like to work with the Azure cloud. I'm not really familiar with AKS or with Google, but I know that both these platforms also have messaging services. And sometimes the amount of messages is just too much for your system to be able to handle. And this is where CADA comes in. CADA can look at your messaging system. So if you have a queue, you can tell CADA, hey, look at that queue. And when the amount of messages stack up, then probably my system isn't able to handle the messages. So you need to scale up the service so I can process all the messages coming in. So it allows your service to scale depending on events that happen in your system. That's really powerful. Dapr, the distributed application runtime, it allows you to communicate with other services in your Container Apps environment. But again, this is just Kubernetes, so you can even use the container name if you like. You don't have to use Dapr. but Dapper comes out of the box with the resiliency built in. So that means that if your request fails, it will handle retry mechanisms, and you can configure it to use a circuit breaker. So if a service is really down, stop hammering it, because we identified it's down. We just accept it for now and wait for the cluster to repair that service, and then we go ahead and hammer it with traffic again. Does it make sense? Yep, people nodding, nice. There are a couple of tools in Dapper. So there's pops up for the messaging, so it can take care of messaging for you. And Dapper is really an abstraction layer. So you communicate with Dapper, hey, I want to publish a message, or hey, I want to handle a message. And you configure Dapper to use an underlying message mechanism. So talking about the service bus, you can configure Dapper, hey, under the hood, use service bus, or under the hood, use event grid, or under the hood, use Redis. There's someone behind me. So that's really awesome. And the advantage of that is, why would I introduce a new abstraction layer? Because abstraction is harder to maintain. It makes my code base a little bit more complicated. But the ease of Dapper is that it runs on your local machine. So you can configure your service or services to use Dapper, and then configure Dapper to, hey, on this local machine, use my Redis container, or use my whatever I run localhost to get everything up and running. And then you can use your complete system to spin up all the microservices that you have to run your entire software ecosystem at once. And then when you bring that to container apps, you don't have to change a single line of code. The only thing that you need to do is configure Dapper components in the cloud environment. And tell Dapper, hey, now on my local host you used Redis, but now we're in a container apps in a container environment in the cloud. Use this service instead, without having to change a single line of code. And I think that's very powerful. It's only configuration. So it looks a little bit like this. You have a service all the way on the left. The gray area is where the Dapper magic happens. And the configuration tells it to either either communicate with Redis cache or Azure storage or whatever. So that part is just configuration. I'm going to move on a little bit because I have a couple of minutes left. So I want to introduce you to Whack-A-Mole. So please already grab your mobile device, because we're going to play a game with the entire audience. Very awesome. Whack-A-Mole is a grid of 3 by 3, and moles start popping up, and you need to tap the moles as fast as possible. But I created this solution entirely in Azure Container Apps. So the first container that you will hit is a reverse proxy, and that is my traffic manager. And that will redirect traffic to the appropriate service. So I have 4 services. One is a user service that identifies you as unique players of the game. One is a real-time service that allows me to do real-time communication and push information to your device. One is the score service, so when you actually tap a mole, I will go ahead and track the score. So I know that in the end who's the winner. And there's a game service that allows me to create a new game and control everything that's happening. Under the hood, there's Dapper, and in this case I use Dapper, the Dapper state store, which is, for me, a distributed cache mechanism. So when one service stores a value in cache, another service can grab that value and use it. So I don't have to do intercommunication between the services. I use the cache layer instead. And in the end, there's an integration layer. And that integration layer is how I build or host the entire service in my cloud environment. So this is how I created it. There's a couple of GitHub repos with GitHub Actions actually deploying it. The integration deploys my application landing zone in Azure. We'll dig a little bit into that later. And for each and every service, quite similar, GitHub repo, GitHub Actions, then build and push the container to container registry and use infrastructure as code to make a deployment in my cloud environment. And the cloud environment will create a revision, pull the container, run it for me, then flick the switch, and my new container is up and running. My infrastructure in Azure looks a little bit like this. So if you're familiar with Azure, then you know that everything that has a unique life cycle needs to be created in a separate resource group. and that is for maintenance. So I have a couple of life cycles here. So each service has its own life cycle because I want to be able to deploy it independently. When something is wrong with the game service, I want to be able to fix it and only deploy the game service without having to bother all the other services. But first, all the way on the left, there's my integration environment, and that is the plumbing that I need for all these services to run. So this has its own life cycle. It is deployed before I can actually deploy one of the other containers. And then I deploy all the apps on top of it. I see people leaving, but they're not able to play the game then. Too bad. All right, so to the demo environment. Let's first open this integration environment because I want to show I have application insights running. And let's put the live metrics on. And if everything is fine, then you will see that my containers are up and running. Oh, this one freezes the screen. Yeah, so my containers are up and running. And for each and every container, you see that there's only one instance up and running. There's one games, there's one proxy, there's one real-time, there's one scores, there's one users, there's one vouchers. Vouchers is not used here. That's when you create another mechanism that allows me to demand users to scan vouchers. So now we're going to play the game. And if you're good enough in the game and tap enough moles, I will receive a lot of traffic. And that will cause this system to scale up dramatically. And I now realize that I need to go to this one. Yeah, log in. And then create a new game. So please now go ahead and grab your device and then scan this QR code, and that will bring you to the game. It pops up and you need to enter a name. Please use an appropriate name. We have a code of conduct for the entire conference, so use something nice. It also asks for an email address. You don't have to fill out that email address. I will spam you. And then when you entered your name, you need to enter a game code that is 0HOCBP, or there's a scan icon all the way on the end, and when you scan the QR code again, you will immediately join the game. I will wait 10 seconds for people to be able to join the game. I see some people scanning, which is nice. 5 seconds. Let's see. All right. There's already a lot of you in the game. And I do see nice names only, so that's awesome. All right, 5. Oh, I have 5 minutes left. 4, 3, 2, 1. So if you didn't make it to the game by now, you won't win anyway. So I now activated the game, and within a couple of seconds I will start the game. It will take 30 seconds, and moles will start popping up on your phone. Please tap the mole as fast as possible. It will measure your response time, and in the end it will come up with an average response time, and the one with the lowest response time is the fastest, so that is the winner. All right, everyone ready? 3, 2, 1, let's go. So if the game didn't start and something went wrong with the real-time communication, you can refresh the screen and it will go ahead and restart the game for you. I see some people tapping. And if I keep on talking, I will distract them. So to make the scoreboard, you need to tap at least 50 moles for the simple reason that I'm measuring an average score. And it really doesn't make sense for you. If you're really fast on the first mole, then it's not an average. See what's happening in the backend. Oh, yeah. So I see a couple of dependencies and requests coming in. The game stopped? Yeah, all right. So please keep the screen open because it will show a scoreboard in a couple of seconds. But first I want to dive a little bit deeper into this dashboard, because now you see that you all joined the game, and that causes the game service to scale up because it received a lot of traffic. And then obviously all the way on the bottom here, these are the score services. And those are also ramped up to 6 instances by now. And that is obviously because I configured this cluster to scale very dramatically. So as soon as it receives the first traffic, go ahead and scale very wildly. This is not necessary in your production environment, but this is for the purpose of this demo. All right, so every 30 seconds, every 10 seconds, Container Apps does an assessment whether or not it needs to scale up, depending on your rules. And those can be HTTP rules, or those can be rules that you configure in Keda. And every minute, it will do an assessment whether or not it can scale back down. And you can scale your services all the way back down to 0, and then your containers don't cost anything. They're free. All right, back to the game. So let's go ahead and finish the game. And by now, oh, something went wrong. OK, I don't see the scoreboard. You do, if I'm correct. So, oh, there it is. So it's Souf. Souf is the winner. Who is Souf? All right, Souf is all the way down with the white sweater. Big round of applause for Souf. You don't hear it with the headphones on, but this applause is for you. So I started 5 minutes late, and I ran over 5 minutes late. So I assume it's about time to stop my my session. If you're interested in how I configured this and how I deployed everything in Azure, I'm happy to show it. But for me, it's now time to leave the stage. And again, any questions, I will take them right next to the stage. And please, if you leave your headphones in the bin. Or if you like some fun, take it to a different stage. Then you see someone talking and you hear something completely different. That's awesome. No, but kidding, just leave them in the bin so other people can use it. And I want to thank you for joining my session and wish you a nice remainder of the conference.